from Achievers, and welcome to my lecture series on chemical kinetics, and this is the second lecture on chemical kinetics. So we have already developed the fundamental idea about the subject chemical kinetics in our very first lecture. Now we'll move on to some explorations in context to chemical kinetics. And for this purpose, we need to define a very important term. The term is extent of reaction. Extent of reaction, which is denoted as xi. Extent of reaction, which is denoted as xi. So this was the fundamental physical parameter in context to chemical kinetics. Okay. Basically, this was first coined, this term was first coined in the year 1922. This term was first coined in the year 1922 by the famous physical chemist T.D. Ronder. T.D. Ronder. So the concept of xi was introduced in the year 1922 by the famous physical chemist T.D. Ronder. So let us discuss this concept now. So for this purpose, let us choose a reaction. Let us choose a reaction, obviously with time independent stoichiometry. Choose a reaction with time independent stoichiometry. Let us choose a reaction with time independent stoichiometry. And let this reaction be AA plus BB leading to CC plus DD. The small letters correspond to stoichiometry and the capital letters corresponds to the chemical components participating in that particular chemical reaction. Now students, since both the sides are balanced, we can use an equal sign to represent it. And that is the convention to represent an equation that is already known to all of us right from our secondary level. Now, what is a change? A change refers to the difference between final and initial. Now here you have got two sides, the right hand side and the left hand side. The right hand side represents the collection of products, so this is final. And the left hand side represents the collection of reactants, so this is initial. So we can say that the change is F minus I, final minus initial. So the change is referred to as CC plus DD minus AA plus BB. And that is equal to 0 because both the sides are same. One can also write this in this way, plus small c plus small d, capital D, plus minus A small a capital A plus minus small b capital B, this is equal to 0. One can always write it in this way. One can always write it in this way. Same representation. This is in short represented as summation over nu I equal to 0. This is the most general representation. This is the most general representation in chemical kinetics. This is the most general representation of any chemical reaction. Most general representation of any chemical reaction. This is the most general representation of any chemical reaction. This is the most general representation of any chemical reaction. So what we have got? We have got a chemical reaction represented like this. It is now converted into a form like this. And then it is given a generalized representation like this. Now you have to decipher the meaning of this general representation. You have to decipher the meaning of this general representation. You have to decipher the meaning of this generalized representation. How can we do that? How can we decipher the meaning of this generalized representation? See, here small I refers to the set of the chemical components involved in the reaction. Small I refers to the set of the chemical components involved in the reaction. It refers to the set of chemical components, set of chemical components involved, set of chemical components involved. A and B are reactants, C and D are products. And nu I, it is the set of stoichiometric ratios, set of stoichiometric ratios. Set of stoichiometric ratio. So, when you just look into this equation, when I is capital A, nu I is minus A. So, when I is capital A, nu I is minus A. So, you have this term. When I is capital B, when I is capital B, nu I is minus B. So, I have this term. When I is capital C, nu I is plus small c. So, you have this term. And when I is capital D, nu I is plus small d. So, I have got this term. So, you can see for the reactants, nu I is negative. Nu I is negative for the reactants. And for the products, you can see nu I is positive. Nu I is positive for the products. So, this was the concept given by D. Donder. D. Donder said that the stoichiometries are constant, and the set of stoichiometric ratios is given by minus A minus B plus C plus D. So you can see that the stoichiometric coefficients are negative. Stoichiometric, write it coefficients, not ratio, coefficients. The stoichiometric coefficients are negative for the reactants and positive for the products. It's negative for the reactants and positive for the products. So you have a general concept for any reaction. You have summation nu I equal to 0. This is any chemical reaction where nu I, it's positive for products and it's negative for reactants. So this is to be remembered. This is to be remembered. This is the concept that I have gathered from here. Okay. Now it's time to understand the concept of Xi, the extent of the reaction. So in 1922, T.D. Donder, he basically proposed a very important and legendary expression in context to chemical kinetics, and that is the fundamental equation on which the entire subject of chemical kinetics stands. And the equation is given by Ni equal to Ni0 plus nu I Xi, where Ni is a function of time, Xi is also a function of time. So write it in this way: Ni as a function of time equal to Ni0 plus nu I Xi as a function of time. You can write it in this way. Now, students, you need to know the meaning of the terms. The meaning of the terms. This is very important. You need to know the meaning of the terms. So at first, what is the meaning of NIT? Then Ni0, then nu I, then Xi. Basically, NIT, it is the number of moles. It is the number of moles of component I at time t, at t equal to t. It is the number of moles of component I at t equal to t. Ni0, it is the number of moles of component I at t equal to 0. Nu I, it is the stoichiometric coefficient of component I. And Xi t, it is the advancement, factor of the reaction. It is the advancement factor of the reaction. So this is the fundamental equation. This is the fundamental equation. And this fundamental equation has some terms. So I have depicted the meaning of NIT. It is the number of moles of component I at time t. Ni0, it is the number of moles of component I at time t equal to 0. Nu I, it is the stoichiometric coefficient of component I. And Xi t, it is the advancement factor of the reaction. Now from this discussion, can you say which of these four terms is unique, or it's an odd one out? Out of these four terms, Which term is odd one out? Can you identify that term? Can you identify that term? That which term is the odd one? And which term is the odd one in context to the other terms? Can you identify that term? The answer is very clear. You see, Ni has got a suffix I. That means it is related to component I. Ni naught has also got a suffix I. That means it is related to component I. Nu I has also got a suffix I and it is related to component I. So all these three terms are basically component dependent terms. Component dependent terms. But what about xi t? Xi t does not bear any suffix I. Xi t does not bear any suffix I. That means xi t is devoid of the component dependence. It is component independent term. It is component independent term. It is component independent term. Now you have to understand the meaning or the logic behind this fact. You have to understand the logic behind this fact, and then only you can understand the essence of the parameter, the extent of the reaction. It is not a component dependent term. So, before getting into that, let us rewrite this equation like this. Xi t equal to, we can make xi t the subject of the formula, is equal to nit minus ni0 divided by nu I. We can always write it in this manner. We can always write it in this manner. Okay. And from here, we can reveal the essence of xi t. Okay. So before getting into that, let us summarize all the equations what we have studied till now. Let's do that at first. So what I have done? We have got a general chemical reaction represented as summation over nu I equal to 0. This is the generalized expression, number one. And you have got nu I, it's positive for products and it's negative for reactants. You have got that. Okay. And what else you have got? You have got nit equal to ni naught plus nu I xi. And you know the meaning of all the terms. But you have to understand this equation a bit more in physical terms. Okay. For that purpose, we have rewritten this equation as xi t equal to nit minus ni naught divided by nu I. Okay. So this is our equation number 2. Okay. So far so good. So far so good. Now I was telling that in this particular equation you have got 4 terms: nit, ni naught, nu I, xi t. Out of these 4 terms, 3 terms, ni naught, nu I, they all bear suffix I. That means they are component dependent terms. But xi t is found to be a temperature dependent term which is independent of the components. Acha. That is to be revealed a bit more. That is to be analyzed a bit more. So for that purpose, at first we need to understand the meaning of or the definition of xi-t. How can we define xi-t? Points about xi-t. Definition. How can we define xi-t? You can see it is the change in number of moles of component I in time t divided by the stoichiometric coefficients. So change in number of moles of component I in time t. Nit is the number of moles of component I at time t minus Ni naught. It is the number of moles at time t equal to 0. So it is the change in the number of moles of component I in time t per unit stoichiometric coefficient. Change in number of moles of component I in time t per unit stoichiometric coefficient. Change in number of moles of component I in time t per unit stoichiometric coefficient. Change in number of moles of component I in time t per unit stoichiometric coefficient. Now you see, it is time dependent term because you have one time dependence here, so time dependence should be here. Ni naught and nu I are time independent. We know the stoichiometric coefficient is time independent, and Ni naught is the number of moles at time t equal to 0, so it is ought to be time independent. So xi-t, it's time dependent but component independent. It does not depend on the component. Why? Because you see, in the numerator you have component dependence. Ni naught, both are component dependent. And in the denominator you have nu I, which is also component dependent. So these two component dependence will cancel each other. These two component dependence will eventually cancel each other. And with the cancellation of component dependence, xi-t will be free from any component dependence. So it must be a component independent term. So we have understood that. Okay. Now you see, for the reactants, Nit is less than Ni naught, because with time the number of moles will decrease. With time the number of moles will decrease, because the number of moles of reactants decrease with time, we know that. So Nit is less than Ni naught, and also for reactants we know that nu I is negative. So you can see both the numerator and denominators are negative. Nit is less than Ni naught, so Nit minus Ni naught is negative, and nu I is negative, so negative by negative is positive. That makes xi-t positive. What happens for product? For product also you'll see xi-t is positive. How? Because for product, NIT is greater than NI naught. Because the number of moles are increasing. So NIT is greater than NI naught. And nu I is also positive. That's known to all of us. So NIT minus NI naught is positive for product. And nu I is positive. So positive by positive is positive once again. So xi t is always positive. That makes xi t always positive. It's always positive. It is always positive. Xi t cannot be negative. It is always positive. And it is same for all the components. So it is the property of the chemical reaction at a particular time. It's only dependent on time and the chemical reaction. That's why we have defined it. It's the advancement factor of the reaction. So xi t is basically the time dependent property of a chemical reaction. Xi t is basically, the fourth point is xi t is basically the time dependent property, of a chemical reaction. So it is ought to be same for all the components. It is ought to be same for all the components. So that's all about the concept of the extent of the reaction. So we'll proceed into the next part of our lecture after this particular class. So thank you all. Bye bye for now. And this is the end of our lecture 2. See you very soon. Bye bye.